Today, I'm going to introduce the concept of human data archaeology and show you one objective: to encourage the adoption and creation of a national authority index. I am a data scientist interested in past human data, and I'm writing up my PhD thesis with the University of Birmingham. Most current members of the digital humanities family are strongly humanities-based, where the term digital denotes that a historian, for example, uses digital methodologies and technologies to complement what would otherwise be the application of more traditional practices in a school of history. But digital humanities as a discipline is now sufficiently broad and extending well beyond the school of history, and sufficiently mature for practitioners to begin to pay close attention to the nature of past human data in itself, what it is, and how it relates to the sources from which it derives. The rapid move to the semantic web invites more and better connected data, and genealogy is a major contributor to the systematic and universal finding, organizing, and managing of human information when it transits from source to data, and yet genealogy is a poor relation in academia. The scientific study of the interface between the hopefully durable digital world of past human data and the degrading physical world of the sources at archive from which it is derived is here called human data archaeology. Human data archaeologists are concerned to preserve the records of person names and their attributes, called name information, as they are found in sources at archives and in collections, where, how, and in whatever form they appear. They are concerned with how all records of name information are present in sources and are then represented or not in the digital world as name data, and the limitations and vulnerabilities of these representations. They are concerned with maintaining the essential but easily broken linkages between name information found in sources and their representative name data found especially in the digital world, and how to preserve those linkages over time. They critically analyze the advantages and limitations when and where sources and data interact, and where name data inevitably must be used as a substitute for named information found in its source. Human data archaeologists make significant new scientific and cultural contributions, for instance, when they work to support the development of data infrastructures and the technologies that help to find and reveal the many linkages between past human lives at both the individual and collective levels, working across both academic and national boundaries. Human data archaeology encourages the application of semantic web concepts to organize and structure data about the human past. For example, by promoting the universal authority indexing, the efficient use of persistent identifiers for all representations of human names found in sources, and the use of technologies such as knowledge graphs to help network them. Human data archaeology brings together genealogy and the humanities. It helps traditional humanities researchers to bridge from the world of sources to the world of data, and it extends and deepens the possibilities of customary research. It offers information on all past human lives as a future data resource to wider academia, and that includes the sciences. My thesis explores how digital technologies might be used by historians or other researchers to explore the modern era, using open source and widely used technologies wherever possible. I looked at the names of persons appearing in the membership lists for a group of societies that the Royal Anthropological Institute in London generally accept as precursors to the formation of the Anthropological Institute in 1871. These societies stretch back some 40 years from 1870 to about 1830. 3,000 names, and amongst them 600 Quakers, were found in the sources examined, and these you can see represented digitally. They are distributed in a Gephi network graph visualization, clustered around the founding societies. Several persons were found to be members of more than one society, and some of these make small influential networking groups of their own, and you can see them here circled. The sources for the member names came from 5 separate archives and in a variety of forms. A widespread problem soon emerged, and it presented major challenges. The loose and variable way in which person names were recorded by authors in the sources. How to translate these multivariant names into a database comprising of one record for each person became a headache. And this headache is shared by all researchers into past human lives. For example, the same name often appears twice in one membership list, as if the same person attended the same meeting twice. A person might be junior in 1830, but senior in 1860. Membership lists were compiled by society secretaries, and so when the secretary changed, the style of name recording in the manuscripts would also change. To resolve this common problem, a project authority index was devised and compiled. An authority index that at the same time recognized and digitally annotated the original form of the name as it appears in the source. This is a common problem for all who build datasets, where the individual record key field is to be a person's name, and therefore each researcher must create their own individual authority index for each database they build. This practice does not meet FAIR principles, because no two authority indexes will necessarily be the same, making cross-working by linking databases problematic. Linking databases with uncertain indexes is a difficult and often impossible task, and especially so if the path from database record to its originating source is not made explicit or preserved over time. This family tree is taken from the index to the Hodgkin family papers held at the Wellcome Institute, London. It shows the genealogical relationships for a key figure in the study, Thomas Hodgkin, MD, 1798 to 1866. We can see that there are indeed 2 John Hodgkins, with John Hodgkin number 2, called Junior until his father's death in 1845, number 1. And there are also 2 Thomas Hodgkins, with Thomas Hodgkin Jr., number 4, the nephew of Thomas Hodgkin, MD, number 3. Given that the purpose of the population study is to find the social networks that connect 3,000 individuals, and that several historians have already named Thomas Hodgkin, MD, as a key influencer in network building, understanding the family relationships of Thomas Hodgkin is important. The genealogical record shows that Thomas Hodgkin, MD, married late, and that he had no children. His brother John Jr., on the other hand, married 3 times and had at least 13 children. See the shaded area. It was Thomas Hodgkin's brother's family that supported Thomas Hodgkin's activism, because it turned out many of them appear as members of the target societies. John Jr., however, is absent from the several histories of the life and activism of Thomas Hodgkin. We can see that genealogy is the best source of help to resolve the common problem of identifying person names that appear in sources in a consistent, rigorous, and comprehensive way. Genealogists, through well-established disciplines and tested techniques, are practiced and adept at the rigorous identification of persons mentioned in sources. At the heart of the genealogist's methodologies lie the general records, birth, marriage, and death certificates. These general records are available, if sometimes patchily. In the UK, they are the property of the General Records Office, in a series beginning from 1837. Before that, parish records provide equivalent birth, marriage, and death records. These general records provide coordinates to help identify individuals: father, mother, date of birth, and location. And these can help researchers to differentiate and make determinations between the multiple and variable appearances of person names in sources. It is possible, I suppose, that an individual might have two birth records, but that likelihood is exceedingly rare indeed. Nonetheless, uncertainty remains, because the past as it appears to us in the sources is incomplete and often frustratingly inconclusive. It is the NIA itself that is formally structured and made universally applicable. But it is still never going to be easy to conclusively cross-reference names appearing in sources with those in a national authority index based on general records. Therefore, the building of a national authority index must allow for individual researchers and genealogists to make and argue their own allocations from sources to NAI. Multiple allocations by researchers and genealogists must be facilitated. Past human data is messy and has permanent uncertainty, which must be respected. Therefore, multiple UUIDs must be allocated for every person name appearance at source, because past names and relationships can be, and often are, disputed. Two or more genealogists or researchers must be allowed to claim the same person for different allocations, and the system must be researcher permissive. This is appropriate for both NAI index building, archive collections, and individual researcher allocations, and to enable the wider disciplinization of the digital representation of person names and their attributes through the adoption of UUIDs. The data needed to build a natural and widely accepted national authority index structure already exists: UK citizen birth certificates or their records. Birth certificates provide four verifiable coordinates: father, mother, location, and date. Later, attributes such as occupations can also be added. A huge number of genealogists already routinely work with natural NAI index data. Therefore, a national NAI can be established relatively quickly. Archivists and researchers can then use AI to build relationships between person names, and not just those identified in academic metadata such as Dublin Core. A model that we might consider as a kind of template could be Google Scholar. After all, if we build the NAI, it would be preferable and efficient if it was a sort of extension to Google Scholar. The NAI might then look like the outline illustration offered at the end of this presentation. And so, what if an NAI engine and the NAI system of UUIDs had been fully in use when I did the research for my project? FAIR principles, findable, accessible, interoperable, and reusable, would have been fully implementable. Relevant data could have been quickly found using the NAI engine. Data could have been collected from many archives and databases, for instance, the National Archives, the British Library, the Bodleian, the Wellcome Institute, to name only those in the UK that would have been of particular use in my studies. Data found in other databases could have been more easily and confidently integrated into the project. The project database would have been easily findable and reusable by other researchers. Additionally, the 10,000 known name attributes revealed by my study could have then been used by AI to identify even more enriching data, findable in other archives. Rich social network analysis and prosopography need not take years to research. Deeper structures and patterns of social interaction would have emerged over the 40-year time span of the study. This schema illustrates the entire NAI concept in one image. We can consider the world to be in two halves, separated in time by digitization, with the branches and leaves of the tree of knowledge appearing around the year 2000 into a digital world. Researchers here might first consider information that is in digital form as data, and only secondly information in non-digital forms from sources. This is a hybrid world with mixed digital and pre-digital information, and over time data will inevitably become more common than pre-digital information in sources. Below the surface, we move into the past, where information is commonly found at archives and collections, institutions that collect and preserve human pasts. Of course, past information exists outside of these institutions, for example, the built environment and the landscape, but the NAI index and its system can be used wherever person names are found in sources. Person name information in archives is mostly locked in documents of one sort or another. Many of these documents are now digitized, but not all. Archival libraries can often be read and searched digitally using discrete and local search engines held on the intranet at each archive. And those search engines will primarily invite author searches because the focus so far has been on the digitization of author names through the adoption of the Dublin Core standard. Little effort, however, has been put into the digitization of embedded person names. Moreover, archival search engines are not operational at the level of the internet. Name indexes can appear at the end of documents, but these are not usually searchable. To contribute to the building of the NAI system, each archive can use AI to find embedded person names and then allocate each incidence of a person name a UUID. There may be multiple names in any given document, and they can then be attached to the Dublin Core metadata record by an extension for each document. Each archive would then be able to compile its own archival name incidence index, and that in turn can then be resolved by AI to the National Authority Index. This might sound like, and it probably is, a lot of work. But AI can help with the workload, and the task can be undertaken progressively, even using volunteers in the form of researchers and genealogists who can be invited to build the indexes as they reveal person names in the course of their own research. The overarching aim of the NAI concept and system is to plant one knowledge tree that allows every researcher to contribute to its nurture. The knowledge tree, therefore, is not fixed as if frozen in time. It shimmers in the sunlight, and it has its seasons, and it grows naturally, nurtured by the constant attention of researcher and genealogist gardeners. Better one well-managed knowledge tree than a forest of poorly tended and often neglected trees. So how does the NAI work? How does it connect researchers, archives, and publications? What follows is a brief initial scoping exercise, an example, and no doubt it is imperfect and it needs a lot more work, but it is a beginning. We begin with trying to find a person already present in the NAI based on a birth record by entering a name and whatever is known about the index characteristics, such as mother, father, birth date, or location. The NAI service will then auto-complete the NAI UUID and find its owner when the user selects a name from a pick list. Meantime, for example, at the National Archives, AI is used to attach UUIDs to every incidence of a person name appearing in documents in the archive, and these are auto-attached to records in the NAI engine. AI selects the most likely NAI UUID for that person. The two new UUIDs, the National and the Archive UUIDs, are then attached to the Dublin Core metadata for the document. Dublin Core system may have to be adapted slightly to accommodate this. The link to Google Scholar is now made. Incidences of person names are now discoverable and linked directly to the source document at that location. At the same time, a researcher builds a database where person name is the key field, and the researcher collects data and person names from many archives, together with their archival and NAI UUIDs. The researcher creates their own UUID to identify the person names now located in their database, and that may have many name variant incidences in the research database that the researcher will resolve into its own database person name UUID. The researcher's work is now fully discoverable and will meet FAIR principles. A top-level search now looks like this. Searching for a name in the NAI engine returns an entry in the NAI index. Using the NAI UUID, the engine can return that this person's name appears in a database, which is findable, and also appears in a document in the TNA archives. Over time, with archivists and researchers building the UUID network, this will become a rich researcher aid, complementing Google Scholar and mapping the entire global archive. Finally, we can complete another search working bottom upwards, from a name found in a documented archive to discover where else that name appears in both archives and databases, and also which academic publications the name appears in. Here are 10 reasons to build a National Authority Index. A National Authority Index can be built with volunteer participation using both genealogists and researchers. It grows slowly over time. It brings together research, archives, and academic publications. For instance, the NAI Google Scholar integration. It brings to life FAIR principles by making the past more discoverable with a secure data path back to source. It enables knowledge graphs and the semantic web to be facilitated. It overlays order where there is a natural untidiness which must be preserved, the issue of messy data. It allows multiple allocations where uncertainty is unavoidable. It makes past data more accessible and trustworthy, encouraging data use widely across academia, and not just by historians and genealogists. It includes a system of UUIDs to connect documents to archives, researcher databases, and academic publications, a system that is disciplined and yet flexible. And it is also extensible. Genealogical pathing is possible through the network. Source mapping is possible across multiple archives. And concept take-up is internationally facilitated, as long as another nation state records their births, marriages, and deaths in a systematic way. This is the end of this presentation. I hope you enjoyed it, and perhaps it encouraged you to think more about human data archaeology and the benefits of national authority indexes. Please click like if you enjoyed it, and do contact me by email or in the comments below if you want to know more. Thank you.